Okay, so our first three examples, we're going to solve these real quick here. Again, we're using zero product property because these are given to us in a factored state. We have an expression multiplied by an expression. That's a factored state. So you look at this factor and you ask yourself, what makes x be 0? What makes x be 0 is when x is 0. There's one of your solutions. Now this other factor, x plus 5. What makes x plus 5 be 0? I'm asking this. What makes x plus 5 be 0? You can solve this by subtracting 5 from both sides, but if you can see what you add to 5 to get 0 is negative 5, and just jump straight to that solution, I don't need to see that step. If it helps you make sense of it, please feel free to write that step, but I don't need to see you write that step. So now we're off to the next example. And we're solving x plus 4 times x plus 11 is equal to 0. This is in a factored state, so we can just use that zero product property. What makes x plus 4 be 0? Negative 4. Done. What makes x plus 11 be 0? What do you add to 11 to get 0? You add negative 11. Done. There's your two solutions. And now we have our last problem where we're solving, again, a factor times a factor equals 0. Well, this one might not be as immediately obvious as to what makes that factor be 0. So you might feel more comfortable writing 2x minus 3 equals 0. And what makes this factor be 0 is when 3x plus 5 is equal to 0. Now you have to solve these two equations. You've been solving equations for quite some time, so I don't need to see you show the step of adding 3 to both sides. If you want to, you can. I don't need to see you show the step of dividing both sides by 2. Again, if you want to, you can. But there's one of your solutions. This one, we're going to subtract 5 from both sides. Then we're going to divide both sides by 3. X equals negative 5/3. And there's our other solution right there. Later on, I'll show you a tactic where you can look at this and get the answers real quick.